Hello students. So in this lecture we will discuss exercise 8.3. So in our previous lecture there we have studied we have studied some trigonometric identities like sine square a plus cos square is equal to 1 and 1 plus tan square a is equal to sec square a and 1 plus cot square a is equal to cosec square a. Okay. So in this lecture we will discuss some exercise from 8.3. So let us solve it. Let us see question number 1. So in question number 1 here we have to express the trigonometry ratio sin A, sec A and tan A in terms of cot A. Okay. So here basically we can use trigonometric identity and we can express the trigonometric ratios sin A, sec A and tan A in terms of cot A. Okay. So let us see how to express the trigonometry ratios sin A, sec A and tan A in terms of cot A. So here we know that this identity cosec square A is equal to 1 plus cot square A. Okay. So we know this identity, and if we use this identity then we can able to express sin A, sec A and tan A in terms of cot A. So here cosec A square is equal to 1 plus 1 plus cot square A, and here if we now take reciprocal in both sides then it implies 1 by cosec square A. This is equal to 1 by 1 plus cot square A. Okay, and here we know 1 by cosec A, this is equal to sin A. So 1 by cosec square A, this is equal to 1 by sin 1 by cosec square A is equal to sin square A. Okay, so sin square A, this is equal to 1 by 1 plus cot square A. Okay, and here sin is equal to plus minus 1 by square root of 1 plus cot square A, and here square root of 1 plus cot square A will always be positive as we are adding two positive quantities. Okay, so sin A, this is equal to 1 by sin A, this is equal to 1 by plus of 1 by square root of 1 plus cot square A, and the reason is because 1 by square root of 1 plus cot square A, 1 plus square root of 1 plus cot square A, this will always be positive as we are adding two positive quantities. Okay, so here sin A is equal to square root of 1 by square root of 1 plus cot square A, and we know that this ratio, trigonometric ratio tan A, this is equal to sin A over cos A. Okay, so tan A is equal to sin A over cos A, and however cot A is basically reciprocal of the tan A. Okay, so cot A, this is equal to 1 by tan A, and this is equal to cos A divided by sin A. Okay, so cot A is equal to cos A by sin A, and therefore tan A, this is equal to 1 by tan A. Okay, so sec square A, this is equal to 1 plus tan square A. Okay, we know this identity. So if we use this identity, then we can express the trigonometry ratio sec A in terms of cot A. So sec square A, this is equal to 1 plus tan square A, and we know tan A is equal to 1 by cot A. Okay, so now if we put the value of tan A is equal to 1 by cot A, then we'll get 1 plus tan square A, this is equal to 1 plus 1 by cot square A. Okay, and now if we simplify it, so here we can take LCM cot square A. So this is equal to cot square A plus 1 divided by cot square A. Okay, so sec A, this is equal to square root of cot square A plus 1 divided by cot A. Since this in denominator, this term will always be positive, since here this is actually adding up two positive terms and cot A is also positive, so sec A is equal to plus of square root of cot square A plus 1 divided by cot A. Okay, so here we express sin A in terms of cot A as sin A is equal to 1 by square root of 1 plus cot square A, and we here express the trigonometric ratio tan A in terms of cot A as tan A is equal to 1 by cot A. Okay, and here we express the trigonometry ratio sec a in terms of cot a as sec a is equal to square root of cot square a plus 1 divided by cot a. Okay, so now let us move to next question. So in next question, here we have to write all the other trigonometric ratios of angle A in terms of sec A. Okay, so here we have to write the trigonometric ratios sin A, cos A, tan A, cot A, cosec A in terms of sec A. Okay, so here basically we'll use trigonometric identities. Okay, and we have three trigonometric identities. One is sin square a plus cos square a is equal to 1, and second is 1 plus tan square a is equal to sec square a, and third is 1 plus cot square a is equal to cosec square a. So basically here we will use these identities, and here we'll express the other trigonometric ratios of angle A in terms of sec A. Okay, so let us see how to write all the other trigonometric ratios of angle A in terms of sec A. Okay, so we know that cos A, this is equal to reciprocal of the sec A. Okay, so cos A, this is equal to 1 by sec A. So cos A, this is equal to 1 by sec A. And also we know this identity sin square A plus cos square A, this is equal to 1. Okay, so sin square A plus cos square A is equal to 1. So from this identity we get sin square A is equal to 1 minus cos square A. Okay, and here it implies sin A is equal to square root of 1 minus 1 by 1 minus cos square A, and we know cos A is equal to 1 by sec A, so this is equal to square root of 1 minus 1 by sec A full square. Okay, and this is equal to square root of sec square A minus 1 divided by sec square A, and this is equal to square root of sec square A minus 1 divided by sec A. So here we express the trigonometric ratio sin A in terms of sec A as square root of sec square A minus 1 divided by sec A. Okay, so now let us express any other trigonometric ratio in terms of sec A. So here we have this identity tan square A plus 1, this is equal to sec square A. Okay, so here from this identity we get the value of tan square A, this is equal to sec square A minus 1, and it implies tan A is equal to square root of sec square minus 1. Okay, so since this value will always positive, so that is why tan A is equal to square root of sec square A minus 1. Okay, and we know cot A, this is equal to cos A divided by sin A, and here cos A is 1 by sec A, and we also express sin A in terms of sec A as square root of sec square A minus 1 divided by sec A that we have expressed in our previous slide. Okay, so sin A is equal to square root of sec square A minus 1 divided by sec A. So cot A, this is equal to 1 by sec A divided by square root of sec square A minus 1 divided by sec A. And here this term and here this term and this term will cancel, and this cot A, this is equal to 1 by square root of cos sec square A minus 1. Okay, so cot A in terms of sec A as 1 by square root of sec square A minus 1. Okay, so cot A is equal to 1 by square root of sec square A minus 1. And we know cosec A, this is actually reciprocal of sin A function. Okay, so cosec A, this is equal to 1 by sin A, and we have expressed in our previous slide sin A in terms of sec A. So sin A, this is equal to square root of sec square A minus 1 divided by sec A. Okay, so cosec A, this is equal to 1 by sin A, and this is equal to sec A divided by sec square A minus 1. Okay, so cosec A, this is equal to sec A divided by square root of sec square A minus 1. So here we express all the trigonometric ratios in terms of sec A. So here we express sin A in terms of sec A as square root of sec square A minus 1 divided by sec A, and we express cos A in terms of sec A as 1 by sec A, and we here express the trigonometric ratio tan A in terms of sec A as sec square minus 1. Okay, and cot A, this is actually cos A by sin A, and we have cos A is equal to 1 by sec A, and sin A is equal to square root of sec square minus sec square A minus 1 divided by sec A. Okay, and this is equal to 1 by square root of sec square A minus 1. And at the end, we have expressed cosec A in terms of sec A as cosec A is equal to 1 by sin A, and this is equal to sec A divided by square root of sec square A minus 1. Since sin A in terms of sec A as square root of sec square A minus 1 divided by sec A. Okay, so cosec A, this is equal to sec A divided by square root of sec square A minus 1. Okay, and now let us move to question number 3. So in question number 3, here we have to choose the correct option, and we have to also justify our choice. Why we will choose why we will choose that we have to justify also. Okay, so here we have 9 sec square A minus 9 tan square A. So this is equal to what? So here we have given 4 options. So in option A we have 1, in option B we have 9, in option C we have 8, and in option D we have 0. Okay, so here basically we'll use trigonometric identity. Okay, and then we'll find the value of 9 sec square A minus 9 tan square A. Okay, so let us see how to solve it. So here 9 sec square A minus 9 tan square A. This is equal to 9 into 9 of sec square A minus tan square A. Okay, and we know 1 plus tan square A, this is equal to sec square A. That implies sec square A minus tan square A is equal to 1. Okay, so here this is equal to 1. So 9 into 1, that is equal to 9. Okay, and here in option B we have 9. So hence alternative B is correct answer. Okay, so alternative B is here correct. So here option B is correct. Now let us see second number. So here we have 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta is equal to what? So here we have given 4 options. In option A we have 0, in option B we have 1, in option C we have 2, and in option D we have minus 1. So let us see which option will correct. Okay, so let us solve it. So here 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta, this is equal to 1 plus sin theta by cos theta. Why this is? Because tan theta is equal to sin theta by cos theta. You know that. Okay, so 1 plus sin theta by cos theta plus 1 by cos theta. Sec theta is 1 by cos theta, that is plus 1 by cos theta, times we know cot theta is equal to cos theta by sin theta. So here we put cot theta in terms of cos theta by sin theta. So 1 plus cos theta by sin theta, and we know cosec theta is equal to 1 by sin theta, so minus 7 by sin theta. Okay, so now we can take LCM for this term. So here we can simplify it by taking LCM cos theta in denominator. So this is equal to cos theta plus sin theta plus 1 divided by cos theta. Okay, and here for this term, here we can take LCM sin theta. So here we get sin theta plus cos theta minus 1 divided by sin theta. Okay, and this is equal to sin theta plus cos theta whole square minus 1 square divided by sin theta into cos theta. Why? Because here you can think these two terms in terms of a plus b into a minus b, that is actually equal to a square minus b square. Okay, so here you can imagine cos theta plus sin theta as a and 1 as b. Then if we apply that identity a plus b into a minus b is equal to a square minus b square, then you will get this is equal to sin theta plus cos theta whole square minus 1 square. And in denominator we have sin theta into cos theta, and this is equal to sin. Now you can use the identity a plus b whole square. This is equal to a square plus 2ab plus b square. Okay, so if you use this identity, then we get this is equal to sin theta plus cos theta whole square minus 1 square divided by sin theta into cos theta. Okay, so here if we expand sin theta plus cos theta whole square, then you will get sin square theta plus cos square theta plus 2 into sin theta into cos theta minus 1 divided by sin square into cos theta. Okay, so here basically we expand this term sin theta plus cos theta whole square. Okay, and we get this term, these terms. Okay, sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 divided by sin square cos theta. So here we have sin square plus cos square theta, that is equal to 1. That is actually the identity. Sin square theta plus cos square theta is equal to 1. Okay, so here we put the value of sin square theta plus cos square theta is equal to 1. Okay, so this is equal to 1 plus 2 sin theta into cos theta minus 1 divided by sin theta into cos theta. Okay, so here plus 1 and minus 1 will cancel, and this is equal to 2 sin theta by sin theta into cos theta, and this is equal to 2. Okay, so you can check now option. So in option C we have 2, so here the correct answer is option number C. Okay, so 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta, this is equal to 2. So basically here we first simplify this, and after simplifying then we get the value of this is equal to 2. Okay, so now let us see question number 3. So in question number 3 we have sec a plus tan a into 1 minus sin a divided, this is equal to what? Okay, so how can you think about this question? So here we have sec a plus tan a into 1 minus sin a. Okay, and here in options we have given in option A sec a, in option B we have sin a, in option C we have cosec a, and in option D we have cos a. So among these 4 options, which option will actually will equal to this? Okay, that we'll have to find here. So here how can we find sec a plus tan a into 1 minus sin a is equal to what? Okay, so let us see how to solve it. So here sec a plus tan a, this is into 1 minus sin a. So we know sec a, this is equal to 1 by cos a. Okay, and we know tan a, this is equal to sin a by cos a. So here basically we use this sec a, this is equal to 1 by cos a, and tan a is equal to sin a by cos a. So sec a plus tan a into 1 minus sin a, this is equal to 1 by cos a plus sin a by cos a into 1 minus sin a. Okay, and now if we take LCM in denominator, then you get this is equal to 1 plus sin a divided by cos a into 1 minus sin a. And now you can use here this identity a plus b into a minus b, this is equal to a square minus b square. Okay, so if you use this identity for simplifying this, then you'll get 1 minus sin square a divided by cos a. Okay, and we know this identity sin square a plus cos square a, this is equal to 1. Okay, so if you use this identity, then 1 minus sin square a, this is equal to basically cos square a. Okay, so 1 minus sin square a divided by cos a, this is equal to cos square a divided by cos a. So 1 minus sin square a, this is equal to cos square a. So 1 minus sin square a by cos a, this is equal to cos square a divided by cos a. And here 1 cos a will be cancelled, and you will get cos a. So let us see which option is correct. So here in question number 3, here we have in option A sec a, in option B sin a, in option C we have cosec a, and in option D we have cos a. So here we get, after simplifying, sec a plus tan a into 1 minus sin a is equal to cos a. So here for this expression, basically we used sec a is equal to 1 by cos a and tan a is equal to sin a by cos a. And after simplifying, then we get this term 1 minus sin square a divided by cos a, and we know this identity sin square a plus cos square a is equal to 1, and from this identity we can write 1 minus sin square a is equal to cos square a, and at the end we get cos square a divided by cos a, and this is equal to cos a. So sec a plus tan a into 1 minus sin a, this is actually equal to cos a. So here the correct answer is option number D. Okay, so option number D is correct option here. And now let us see let us see question number 4. So in question number 4 we have 1 plus tan square a by 1 plus cot square a is equal to what? So here in option A we have given sec square a, in option B we have -1, in option C we have cot square a, and in option D we have tan square a. Okay, so basically we have to simplify this and we have to find the value of this. Okay, so 1 plus tan square a by 1 plus cot square is what, that we have to find here. Okay, so now let us see how to solve it. So here we have this 1 plus tan square a by 1 plus cot square a. This is actually equal to 1 plus sin square a by cos square a and divided by 1 plus cos square a by sin square. Why? Because we know tan a, this is equal to sin a divided by cos a. Okay, and we know cot a, this is equal to 1 by tan a, and this is equal to cos a divided by sin a. Okay, so 1 plus tan square a, that is equal to 1 plus sin square a by cos square a, and 1 plus cot square a, this is equal to 1 plus cos square a by sin square a. Okay, and now simplify it, then you will get this is equal to cos square a plus sin square a divided by cos square a divided by sin square a plus cos square a divided by sin square a. Okay, and here we know this identity sin square a plus cos square a, this is equal to 1. So we know this identity sin square a plus cos square a, this is equal to 1. Okay, so here we get this expression cos square a plus sin square a. So we can now put the value of cos square a plus sin square a, that is equal to 1. Okay, and we also put here sin square a plus cos square a 1. So we here get this is equal to 1 by cos square a by 1 by sin square a. Okay, and this is equal to sin square a by cos square a. Okay, so this is equal to sin square a by cos square a, and this is equal to tan square a. Okay, since tan a is equal to sin a by cos a. So in question number 4 here, 1 plus tan square a by 1 plus cot square a, this is equal to tan square a. So let us see which option is correct. So 1 plus tan square a by 1 plus cot square a, this is equal to tan square a. So here in option D we have tan square a. So here the correct answer is option number D. Okay, so option number D is here correct answer. And now let us see question number 4. So in question number 4 here we have to prove the following identities where the angles involved are acute angles for which the expression are defined. Okay, so here we have to prove these following identities. So in first one we have given cosec theta minus cot theta whole square, this is equal to 1 minus cos theta by 1 plus cos theta. Okay, so we have to prove this. So here we have cosec theta minus cot theta whole square, this is equal to 1 minus cos theta by 1 plus cos theta, that we have to prove here. Okay, so to prove it, so here in left hand side we have cosec theta minus cot theta whole square. Okay, so in left hand side we have this cosec theta minus cot theta whole square, and we know cosec theta is equal to 1 by sin theta and cot theta is equal to cos theta by sin theta. So this is equal to 1 by sin theta minus cos theta by sin theta whole square, and this is equal to 1 minus cos theta whole square divided by sin theta whole square, and this is equal to 1 minus cos theta whole square by sin square theta, and this is equal to 1 minus cos theta whole square by 1 minus cos square theta, and this is equal to 1 minus cos theta whole square divided by 1 minus cos theta into 1 plus cos theta. Since a square minus b square, this is equal to a plus b into a minus b. Okay, so here you can write 1 minus cos square theta as 1 minus cos theta into 1 plus cos theta. Okay, so 1 minus cos theta whole square, this is divided by 1 minus cos theta into 1 plus cos theta, and here 1 minus cos theta will cancel, and this is equal to 1 minus cos theta by 1 plus cos theta. Okay, and this is the right hand side. So here left hand side is equal to right hand side, so hence proved. Okay, so cosec theta minus cot theta whole square, this is equal to 1 minus cos theta divided by 1 plus cos theta. And now let us see second one. So in second one here we have to prove that cos A by 1 plus sin A plus 1 plus sin A by cos A. This is equal to 2 times sec A. Okay, so let us see solution. So here cos A by 1 plus sin A plus 1 plus sin A by cos A, that is equal to 2 sec A, that is to prove it. Okay, so here left hand side we have 1 cos A by 1 plus sin A plus 1 plus sin A by cos A, and this is equal to cos square A plus 1 plus sin A whole square divided by 1 plus sin A into cos A, and this is equal to cos square A plus 1 plus sin square A plus 2 sin A divided by 1 plus sin A into cos A, and this is equal to sin square A plus cos square A plus 1 plus 2 sin A divided by 1 plus sin A into cos A. Okay, and if we further simplify it, then we'll get this is equal to 1 plus 1 plus 2 sin A divided by 1 plus sin A into cos A, and this is equal to 2 plus 2 sin A divided by 1 plus sin A into cos A, and this is equal to 2 times 1 plus sin A divided by 1 plus sin A into cos A. Here 1 plus sin A, 1 plus A we cancel, and this is equal to 2 by cos A, and we know 1 by cos A is equal to sec A, so this is equal to 2 sec A, and this is the right hand side. So here left hand side is equal to right hand side, hence proved. And now let us see question number 3. Here we have tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus sec theta into cosec theta. Okay, so here left hand side this and right hand side this. So here we will first start from left hand side, and after simplifying then we will show this is equal to this. Okay, so let us see how to solve it. So here tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta, this is left hand side. So left hand side this is equal to tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta, this is equal to sin theta by cos theta divided by 1 minus cos theta by sin theta plus cos theta by sin theta divided by 1 minus sin theta by cos theta. Okay, so if we simplify it, then we will get this is equal to sin theta by cos theta divided by sin theta minus cos theta by sin theta plus cos theta by cos theta minus sin theta by cos theta, and this is equal to sin square theta by cos theta into sin square theta minus cos theta, sin square theta minus cos theta minus cos square theta by sin theta into cos sin square theta minus cos theta. Okay, and if we further simplify, then you get this is equal to 1 plus sec theta into cosec theta. Okay, so left hand side is equal to right hand side, hence proved. So here we have question number 4. So in question number 4, here we have in left hand side 1 plus sec A by sec A, and this is equal to in right hand side sin square A by 1 minus cos A. So here I will give you hint how to solve it. So here basically you have to simplify first left hand side, and after simplifying left hand side you will get right hand side. Okay, so here left hand side is right hand side, hence proved. And for fifth one, here we have cos A minus sin A plus 1 divided by cos A plus sin A minus 1 is equal to cos A plus cot A. So here you can, using the identity cosec square is equal to 1 plus cot square A, and if we simplify it, then you will get this is equal to this. Okay, so left hand side is equal to right hand side, hence proved. And for sixth one, here we have square root of 1 plus sin A by 1 minus sin A is equal to sec A plus tan A. So for proving it, you have to first simplify left hand side, and then you have to show left hand side is equal to right hand side, then hence proved. Okay, so these are your homework problem. So in a seventh one, we have sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. Okay, so left hand, you have to simplify left hand side and right hand side, then you will get left hand side is equal to right hand side. Okay, then you can prove. So I stop here this lecture. Thank you very much to all of you.